Hi students, I welcome you all to this class. So in this class we are going to see a new unit that is about analysis and design of T-beam. So this unit is your 6th unit in your SPT syllabus. So according to your syllabus, if you see, you will have brief introduction in your syllabus, and then you will have analysis part, and then you will come to design part, and you will have simple. So you have to solve some problems. That's all about. Okay. So today we are going to see about the introduction part only. In this lecture, we are going to see only the introduction part, and in next lecture, I am going to teach you the analysis and design. Okay. So I'm going to divide into two parts this unit, so in order you will have a better understanding. Okay. So first, what is the unit name? What is unit name? Analysis. 1 minute. Analysis and design of T-beam. Analysis and design of T-beam. Okay. First, what is T-beam? First, I will explain you what is T-beam. T-beam, how that beam name is called as T-beam. First, you must understand what is T-beam. Okay. Due to its cross section is in a shape of T, that is why we are calling it as T-beam. See, for example, this is the T-beam. This T-beam. Due to its cross section is in T shape, we are calling it as T-beam. And also, the T-beam is nothing but the beam which is cast together with the slab. That is, in your normal construction and all, if you go and see the slab casting, the roof slab casting, you can note that the slab alone they will not cast in the construction. They will cast along with beam. The beam and slab will be casted along together. So likewise, so this is beam and this is slab. The beam and slab casted together and they form a shape. See, for example, I am drawing another diagram. See, this is slab and beam. Slab and beam. Okay. This is slab and beam. See, in this intermediate beam, this beam has both the sides slab. See, this side also it has slab, this side also it has slab. So this beam is considered as T-beam. But if you see the left hand side, it doesn't have both the sides slabs. It has only one side slab. So this shape is what? This is an L shape. So this beam is called as L beam. And this beam is also called as L beam. Suppose if slab extends like this. For example, if slab extends like this, so what is then this beam is also called as what? T-beam. You understand the concept? So the T-beam is a load bearing structure which can be casted in any materials like reinforced concrete, timber, steel, any components, any materials it can be casted. It's a load bearing structure which is in the shape of, its cross section is in the shape of T. And also the T-beam is nothing but it is casted with both slab and beam. It is casted with both slabs and beams. Thus, it is said as T-beam. So now we understand what is the total concept of T-beam, right? So next, according to your unit, it is mentioned as analysis and design of T-beam. So that is your subject, right? Design of structures. You have to design the structure. Design means what? If you are the engineer, you are going to place a structure in a particular area. So you are the engineer, you are going to design what is the height of the structure, what is the breadth of the structure, what is the thickness of the structure, that is the volume, 3D. So that is only, it is called as structure. So you are going to design what is the depth of the structure, how the structure should be looked like, what is its artificial like architectural view, how the external view should be, how the internal view should be. You are the engineer, you must want to design. Likewise, the engineer must also design each and every components of a building. So every components means beam is a component in a building, column is a component in a building, slab is a component in a building, stairs is a component in a building, water tank. So everything, if you are constructing a brick wall or you are going to cast a door, so everything is a component in a building. So combining all together these components is only a structure as a building. Likewise, T-beam is also a component. So what is the work of civil engineer is to design the every part. To design the every part. So I will briefly explain what is analysis. Analysis is nothing but you are going to analyze how much load is going to act on a structure. What is that load that is going to act on a structure? So if a structure is like this, in structure is used for carrying some loads. For example, this is a beam, this is slab, and a beam is there. So over the beam in future, there may be some loads may act. So it has some self-weight in it, and some live loads may be act. UDL, point load may be act. So due to that load, there will be some shear force and bending moment will act on the structure. So the structure should withstand the load. Then only it will not be failed. So what your work in analysis part is, what is the work of civil engineer in analysis part is, he must analyze how much load is going to act on the structure and what is the self load of the structure. So due to this combination of all load, how my soil is going to withhold the structure and how my structure will not be collapsed. This is the analysis part. And in design part, due to this, according to this load, what type of beam I am going to provide, and what is the breadth of the structure, what is the depth of the structure, and what is the height of the structure. You are going to design what height should become. So according to this load, what type of reinforcement bar you are going to use, what type of concrete materials you are going to use, and what type of structure it is, what is the height of the structure. According to the height, what are the pressures. So pressures means I'm telling like wind loads, earthquake loads. So these are sometimes some pressures. So what are the pressures that is going to come? These are analysis part. So according to that, you will design the structure. How much reinforcement bar you are going to provide, what are the materials you are going to provide, what is the breadth, depth and thickness of the structure. That is the part. So in this unit, the introduction is analysis and design of T-beam. So first you must analyze what is the load that is going to happen in the T-beam, and you must design the T-beam. What are the reinforcement bars, what is the depth of the T-beam, breadth of the T-beam, what is the effective cover that you are going to provide for T-beam. So this all comes under T-beam section. Okay. So I will show you. See, this is the L beam as I already draw T-beam. So this top, the portion above the beam, this horizontal part is called as flange. What is called as? This is called as flange. And this beam below the slab, this part is called as web. This is called as flange, this is called as web. And the distance from here to here, in the flange portion, the distance from here to here is called as, it is denoted as B suffix F. That is nothing but what? BF is equal to breadth of the flange, and DF, depth of the flange, DW, from here to here, that is depth of the web, and this portion, this thickness, breadth of the web. That's the small introduction. So the portion above the T-beam is called as flange, below the portion is called as web. Okay. So this fourth point, the intermediate beams having slabs on both sides. Slabs on both sides. That is only I drawn told you. This is T-beam. See, slabs on both sides. This beam, intermediate beam having slabs on both the sides is called as T-beams, and the beams having slab on one side only is known as L-beams. Okay. So next we are going to see simple advantages of T-beams. It is very simple. Okay, advantages of T-beams. Since the beam is cast monolithically with a slab, the flange also takes up the compressive stress, which means it will be more effective in resisting the sagging moment acting on the beam. So this T-beam is more effective in resisting the sagging moment acting on the beam. What is sagging moment? So there are two types of moment, right? Positive bending moment. Positive bending moment is called as sagging bending moment, and negative bending moment is called as hogging. Okay, sagging bending moment is nothing but the bending which occurs in a concave manner, like this. Beam bending. Sorry, this is beam. It is bent in a concave manner. And hogging bending moment is nothing but the beam which is in a convex manner, bent at a convex manner. So this is called as hogging bending moment. So this is sagging and hogging bending moment. So first advantage is this T-beam is more effective in resisting the sagging moment acting on the beam, because the beam is cast monolithically. What is monolithically? Monolithically is nothing but a large structure which doesn't contain any parts. For example, if you take a wall comprises of what? Small bricks. Small bricks formed a wall. But monolithically means there is no bricks, there is no small components. A single unit is called as monolithically. Since this beam is cast monolithic slab, the flange also takes up the compressive stresses, which means since the beam is monolithical, that is the slab and beam is casted along together, monolithic, it takes compressive stress, which means it will be more effective in resisting the sagging moment acting on the beam. So it is more effective in sagging bending moment because it is casted monolithically. First point. Second one, better headroom. This is direct outcome of the first point, since the depth of the beam can be considered reduced. So in normal beam, if you cast for a heavier structure like very high, height of the structure is very high. For the structures, the normal beam depth will be more. But if you take the T-beam, it will make your beam lessen depth. So that is the second point. So since the depth of the beam can be considerably reduced, there will be better headroom. Headroom means the distance between our height to the slab will be better. Third one, for longer spans, T-beams are usually preferred than the rectangular beams. For longer spans, like if you are going to construct a structure which doesn't have columns in between the room. So for longer spans, like support between the beam is very long. In that cases, you can go for T-beams. So the T-beams are preferred. T-beams are usually preferred than rectangular. So only three advantages. Since the beam is monolithical, it is effective in sagging bending moment, and the depth of the beam is reduced in the T-beams. So we will have better headroom, and for larger span rooms, it is preferred. T-beams are preferred than the rectangular beam. Okay. So I hope you understand the introduction of Unit 6. So next part, this is part 1 of Unit 6. In part 2, we will see the analysis and design of T-beam. Thank you, students.